Hey there folks, Mr. Dickin here. In this video lesson, we're not going to be learning anything new, but rather we're going to be going over just a little bit more of our piecewise function content, because with these, especially more practice is good. So, there was a question that was going to be on the online homework assignment that's going to look something like this. Now, this isn't the exact problem. This is just something I made up using Desmos. But the question is going to ask, find the domain and range using interval notation. So interval notation is going to be when we use brackets or parentheses, and we say from some value to some other value. So that's what we're going to be looking for here. All right. Now, with domain is going to refer to the x values. So as I kind of think of this graph and move from left to right, all of these x values at some point, they're defined on the graph itself. Now, -1, something interesting happens, is that's when we switch from the blue line to the red line up here at the x value of -1. So everything prior to that is clearly defined by the blue line, but is -1 defined? Well, yeah, because I can look above, and since there's a filled in dot on the red, we have a function defined at -1. It might not be the blue function, but -1 is still defined nonetheless. And when I say defined, I mean that every x value gets a y value that pairs up with it. Now, if the red circle was also empty, just like the blue, then -1 would not be defined. It would not be in our domain because it does not have a y value partnered up with it. So the domain for this one would actually be all real numbers, or -infinity to positive infinity. But that's not what the question's asking, is it? The question asks us to find the range. So the range deals with all of the y values. So every y value that has an x that kind of pairs up with it is going to be included in the range. Well, I'm noticing that this blue line is going to go down and left forever and ever and ever and ever. Well, if I were to go downward forever and ever and ever and ever, down here on the y-axis, we would just call that -infinity. So my lower limit is going to be -infinity. Anytime infinity is used, you have to use a parenthesis. And part of me wants to say, hey, this arrow goes up forever, so shouldn't we also have a positive infinity and just say negative to positive infinity? Can't really do that here. And the reason for that is we have this kind of region where there's just nothing going on, right? There's this region of nothingness as I traverse up the y-axis. So we're going to have actually two separate intervals for our range. So we have -infinity all the way up to -2, and -2 is an empty circle, so it does not get a bracket. So -infinity to -2. Then we're going to use our union symbol. Remember, this is just a mathy way of saying and. And then we go from 1 to positive infinity. 1 is included, and infinity is never included, so it always has to use a parenthesis. So there you go. Also with these, we should probably write it out on one line. It's kind of janky looking for me to have it line 1, line 2, and line 3, but I ran out of room with the graph, so my apologies there. All right, let's get into what would be the example warm-up if we were seeing each other for this lesson. So you'd have this function in front of you, and you'd be asked to graph it. Again, this is a piecewise function. We have 3 different function rules depending on what our x value is. You know me, I love color coding these things. So I'm going to do the first one yellow, second one will be green, third one will be blue. And it looks like the x values that kind of switch from one function to the other are -1. You see that here, and then +1. So on my graph, I would throw in at -1, throw a little reminder to myself that that's where things change from one to the next, and at +1, things change from one to the next. All right. Next, let's get into our function evaluations. Oops, sorry, let me give this some color coding over here as well. There we go. So now function evaluations. For all of these functions down here, we need to pay attention to what is our x value input, and based on which category it falls into, that'll determine which function rule we're going to follow. So -2 is clearly less than -1, so that would be yellow. -1 would actually follow the green rule, because -1 itself is not included. It doesn't have the or equal portion, but it does right here. 0 would also fall in this region, and then +1 would be in the blue. So now when it comes time to evaluate, we just plug our x value into the corresponding function. So f of -2, yellow function here would be -2 plus 3. That's going to give me 1. -1 goes in for this function, so -1. The opposite of -1 is +1. Minus 1, I get 0. F of 0, -0 is just 0. Minus 1 is -1. And then the last function, f of 1, I'm using the blue function. Well, that's just 1. I should mention as well, if I really wanted to, I could also use these as points when I'm graphing. So for instance, the first value here, I have a point, -2, 1. So if I wanted to, I could graph that. -2, 1. -1, 0 is my next one. 0, -1. And 1, 1. So if I needed these for framework for my graph, I could use that as well. All right, so let's see what the actual graph over here should look like, because I have a formal Desmos screen grab of it instead of me trying to, get all janky with drawn lines in there like that. Here we go. So you'll notice we still have these little boundary zones, if you will, included, because the cutoff would still be at the -1 and at the +1. That's where things change. But the first function is represented with this red line here. The second function is this little stretch in the middle. And then that third function is this purpley region there. So that is it, folks. You know the drill. If you have any questions, please let me know. And as always, good luck, have fun, be safe, roll tide.